All right, let's jump straight into this explainer. Today, we're taking those incredibly dense, highly technical safety checklists and translating them into a master blueprint for structural integrity and, most importantly, human life preservation on the job site. Because if you've ever managed or worked on one of these sites, you know that gravity is completely unforgiving, right? So we aren't just talking about pipes and boards today. We're breaking down the exact anatomy of safe scaffolding.
We're analyzing the official CISRS specifications prepared by CISRS. What does that mean for us? It means every single measurement, every angle, and every requirement we talk about today is the absolute standard for compliance. There is literally zero room for guesswork or approximation when you're building temporary structures dozens of feet in the air. To make this all crystal clear, we're structuring this explainer exactly how a scaffold is actually built. We'll look at Element 1, the base, Element 2, main structures, and finally Element 3, working platforms.
Starting off with Element 1, the base.
We're starting at ground zero, because honestly, the physical earth beneath you dictates your very first and probably most important structural moves. Before you even think about connecting a single tube, you've got to master your spatial clearances, so you need a strict minimum 1.0 meter distance from any excavation edge. Building on sloped ground, you need a minimum 300 millimeter clearance, and for that very first lift, it's capped at a maximum of 2.7 meters high. Why? To ensure safe access and egress right from the get-go. Now check out how the ground conditions completely dictate your foundation. If you're dealing with weak surfaces, soil, sand, or gravel, you're mandated to use a massive sole board. We're talking 450 by 225 by 38 millimeters just to spread that load out properly. But no matter what, whether you're on weak dirt or solid concrete, you absolutely must have a 150 by 150 millimeter base plate on every single vertical standard to safely distribute the weight.
Next up is the kicker lift. This is an optional lowest horizontal brace installed at least 150 millimeters off the ground to make sure everything is perfectly square. But here's the catch, and it's a big one. If you skip the kicker lift, you are strictly required to install a plan brace instead. No exceptions. It guarantees your foundational footprint won't shift or distort when you pile on all that immense overhead load.
Moving on up to Element 2, main structures.
With the base locked in, it's time to build the skeleton. And man, this is where the geometry gets serious. Your vertical standards have to be perfectly plumb and straight, zero damage allowed. Then your horizontal ledgers must be properly leveled and fixed. For the structural transoms, you lock them in with right-angle couplers within 300 millimeters of the node points. Intermediate transoms? Those use single couplers with a max distance of 1.2 meters to support the boards. The big takeaway here is the spacing. Lift heights happen every 2 meters, and the bay width needs to fit a minimum of 3 boards, varying depending on your load classes 1 through 4.
So how do you keep this massive metal grid from just buckling under pressure? Sway bracing. This is diagonal bracing installed at a maximum of every 6 bays, and it literally stops the whole framework from leaning or collapsing sideways. You've also got ledger bracing at both ends of the scaffold. And just like that ledger bracing, sway bracing needs precision hardware placed exactly within 300 millimeters from the node points, which actually brings us to a huge compliance trap.
Listen, you absolutely cannot just mix and match your couplers based on whatever's sitting closest in your tool pouch. For both ledger and sway bracing, you have to use swivel couplers if you're fixing directly to the vertical standards. But, and this is crucial, switch to double couplers if you're fixing to the horizontal ledgers or structural transoms. Using the wrong clamp here fundamentally ruins the bracing's holding power.
Before we head up to the final tier, a quick, vital reality check. You have to visually and physically inspect all tubes, boards, and couplers for damages. Structural integrity is completely out the window if your individual steel components show even a fraction of damage, bending, or wear. A perfect blueprint means absolutely nothing if your raw materials are compromised, right?
And finally, Element 3, working platforms.
This right here is the ultimate danger zone. This is where workers interact directly with the structure at extreme heights, basically trusting their lives to the engineering below them. The floor beneath your feet is governed by strict rules. The platform boards can't have any signs of damage or large gaps, and they must be properly secured. But placing them is just step one. The overhang of the boards past the last transom support must be a minimum of 50 millimeters, but capped at a strict maximum of 150 millimeters. You have to measure that overhang perfectly, so the platform doesn't suddenly turn into a seesaw when someone steps near the edge. Next in the platform architecture is a really specific component, the punch-in. By definition, a puncheon is a short vertical tube used to support a toe board, and it has to be securely fixed to the top and mid railings with double couplers. Think of it as the ultimate reinforcement for your edge protection, guaranteeing that heavy tools, materials, or even a slipping foot won't slide off the side.
950. Seriously, burn this exact number into your memory. 950 millimeters is the absolute minimum height required for your top guardrail, measured directly from the platform. It's the precise height engineered to safely catch an adult's center of gravity and prevent a fatal pitch forward over the side.
What really matters here is how these edge protection pieces work together as a cohesive system. You've got your top guardrail at that 950 millimeter minimum. Below that, the mid-rail must be positioned so there's a maximum 470 millimeter gap between the toe board and that top rail. And at the bottom, the toe boards are perfectly in place and locked down tight with single couplers. Combine that top rail, the precisely gapped mid-rail, and those secured toe boards, and you've basically built an impenetrable physical barrier against falls.
Now, getting onto that protected platform safely is an entire strict procedure on its own, and site inspectors will check every single access clearance. For internal access ladders, the opening has to be exactly 450 by 600 millimeters, while external ladders max out at 1.0 meter. The access landing, completely free of any obstructions. You need a dedicated access gate or at least a self-closing drop bar if a gate isn't there. Plus, a ladder cage must be present for that extra layer of safety during the climb.
Once again, safety comes down to perfect geometry. Here's another magic number to burn into your memory: 75. You've got to anchor your access ladder at exactly a 75-degree angle. Any steeper, and you risk tipping backward. Any shallower, and you're severely compromising the ladder's structural load capacity.
But fixing it at 75 degrees is just part of the sequence. It needs to be securely fastened from the top stile all the way down to the bottom stile. And you have to extend the ladder past the working platform by at least 1.0 meter. Why? Because extending it a full meter above the platform ensures the worker always has a solid, continuous handhold while they're physically transitioning off the vertical ladder and onto the horizontal deck.
As we wrap up this technical breakdown, there is one golden rule threaded throughout the whole CISRS specification: the correct use, securement, and positioning of all couplers at every single stage. You probably noticed this specific rule applies to the base, the main structure, and the platform alike. If your couplers fail, or if they aren't tightened correctly, the math, the perfect angles, those minimum gap measurements, they simply don't matter.
Understanding the precise mechanics of these three main elements doesn't just help you pass an inspection. It guarantees that everyone who climbs up into the sky comes back down safely. So take these exact numbers and constraints back to your site today, because in this line of work, the difference between a minor oversight and a massive tragedy is literally just a few millimeters. So I'll leave you with this. Is your team building upwards on a foundation of total, uncompromising compliance?